Hi everyone, this video is about factoring by grouping. We're going to take some of the skills that we used for finding the greatest common factor of a polynomial, and we're going to use it in this way to find a way to factor a polynomial that sometimes doesn't have a greatest common factor that's identifiable. So let me give you an example here. Here's a polynomial x cubed plus 4x squared plus 3x plus 12. And as we look at this polynomial, we look to see if we can identify a greatest common factor, and we can't. If we look at the numerical values here, and there's a 1 here that we can't see, right? The greatest common factor for 1, 4, 3, and 12 is 1, right? There's nothing, they don't have a factor in common other than 1. And if we look at the variables, x cubed, x squared, x to the 1 power, and then here there is no variable. So that means that there isn't a greatest common factor for, in terms of the variable x, for all 4 of these terms either. So it kind of looks like we're done. But in actuality, we can use this other technique called factoring by grouping and see if we can see if there is some way that we can factor this, and put it into factored form. So we literally do what we're saying. We're going to group. So I'm going to group these two terms together. I'm going to group these two terms together. And for each of these groups, we're going to ask ourselves, what's the GCF of these groups? Is there a GCF for each of those groups? So if we look at this first group here, the greatest common factor for x cubed and x squared, as we've talked about with the previous video, is x squared. So using the distributive property, I want to write this now in factored form. I think to myself, what is x squared multiplied by to get x cubed? And that would be x squared times x. And then I ask, what would I multiply x squared by to get 4x squared? And I'd multiply it by 4. So I've rewritten this group as x squared times x plus 4. For the second group, I'm going to do the same thing. I'm going to ask myself, well, what is the GCF for the second group? And if I look at 3 and 12, the greatest common factor is 3. But for the variable, there isn't one. There is no x here, so I don't have one for x. So then I'm going to do the same thing with the distributive property and say to myself, 3 times what would give me 3x? And that would be x. 3 times what would give me 12? And that would be 4. So now I have these two different factored forms, x squared times x plus 4, 3 times x plus 4, right? And one thing that you should be noticing, right, is that they both have this x plus 4. So what that means is x plus 4 and x plus 4 is in common with the other two, in these two terms. So that is a common factor. And we ask ourselves, well, what would I multiply x plus 4 by to get back to this setup? And I need to multiply x plus 4 times x squared. And I need to multiply x plus 4 times 3. So the x squared and the 3, they end up in the other group. So my factored form is x plus 4 times x squared plus 3. So it all comes down to being able to identify a greatest common factor. So that's why we practiced it in the previous video. Let's look at another example. Suppose we look at 6x cubed minus 4x squared plus 15x minus 10. As I look at all of the coefficients, the numerical values, and this constant here, there is no greatest common factor for 6, 4, 15, and 10 other than 1. And I look at the variable x cubed, x squared, x to the 1, no variable here, so there is no greatest common factor for x either. So we're going to try factoring by grouping to see if this will work. So I put these in a group, I put these last two terms in a group, and then we ask ourselves, what is the GCF for this group? And what is the GCF for this group? So the GCF for this group, for 6 and 4, it's 2. And for x cubed and x squared, it's going to be x squared. And then we ask ourselves, what would I multiply 2x squared by to get 6x to the third? And that would be 3x. And we ask ourselves, what would we multiply 2x squared by to get negative 4x squared? And we would multiply 2 times negative 2, right, because that's negative 4. And I don't have to multiply the x squared times anything. Then we look at the second group and look at 15 and 10. What's the greatest common factor there? And that would be 5. And then again, we think 5 times what would give us 15x, and that would be 3x. 5 times what would give us negative 10, and that would be negative 2. And as we see, 3x minus 2 is in common between these two groups. So one of our factors is 3x minus 2. Our other factor are these two terms outside, 2x squared plus 5. So that would be our factored form for 6x cubed minus 4x squared plus 15x minus 10. So it's all about the GCF. Let's look at another example. How about 4x squared minus 8xy minus 3x plus 6y. So again, looking at the numerical values here, all of the coefficients, there is no greatest common factor other than 1. Looking at the x's, there's an x in this term and in this term and in this term, but not an x in this last term. So there is no greatest common factor for x. Also looking at y, well, y is in the second term and the fourth term, but there's not a y in all of them. So there is no greatest common factor for all of the, for this entire polynomial that involves y. So what we're going to do now is try grouping and see what happens. So this one's a little bit different. We have a minus sign here. So what I'm going to suggest is that you put a parenthesis around that and then put a plus here just to remember that these groups are separated, right? We're not doing multiplication, but that we've separated them, okay? So we want the GCF for the first group, and we want the GCF for the second group. So the GCF for the first group, for 4 and 8, it's 4. For x squared and x, it's x, and then that's it. There is no y in the first term, so there is no, so this is it. So what would I multiply 4x to get 4x squared? I would multiply it times x. What would I multiply 4x by to get negative 8xy? I multiply 4 by negative 2. I multiply x times y so that I can get negative 8xy. Now the second group, I look at the 3 and the 6, and the greatest common factor is 3. But I want to make sure that I end up with the same group that I have right here. So I need to think about the sign that I would use when I take out that 3. And I want to take out a negative 3. And you're going to see why in just a second. Negative 3 times what would give us negative 3x? It would be x. Negative 3 times what would give me a negative 6? And that would be negative 2. Negative 3 times negative 2 is a positive 6. Y, so I can get the y here. So now this term, this group and this group now are exactly the same, x minus 2y. So that's one of my factors, x minus 2y. The other factor would be 4x minus 3. It's this factor here and this factor right here. Okay, so whenever you see a minus sign, this is going to be a minus sign as well. When you see a minus sign in this spot right here. Let's take a look at one more, just so that you can see that again. Let's see, let's look at 2x cubed minus x squared minus 10x plus 5. Looking at the coefficients and the constant, there is no greatest common factor. Looking at the variable x, there is also no greatest common factor. So we can go right to grouping. So I'm going to group these two together. I'm going to group these two together, and I'm going to put a plus here to remind myself that they are separated from each other. Then what's the greatest common factor for this first group? What's the greatest common factor for the second group? So the first group, the greatest common factor is x squared. For 2 and -1, there isn't one, right, other than 1. So 2x minus 1 would be my distributive property here. X squared times 2x is 2x cubed. X squared times -1 is -x squared. I look at the next group. Greatest common factor for 10 and 5 is 5. But because I want to make sure that I have the same factor here, I need to factor out a -5, because -5 times a positive 2x would give me -10x. -5 times a -1 would give me positive 5. So now I have 2x minus 1, 2x minus 1. So something we talked about in class, once you've identified one of the factors here, the second one should be exactly the same, and you just need to figure out what you could factor out to make sure that it looks exactly the same. So one of our factors is 2x minus 1. The other factor is x squared minus 5. So that ends our video about factoring by grouping.